capacitive touch embedded in wood. That's right, I built a custom capacitive touch module that embeds in the backside of wood so you can touch with one finger or multiple fingers and turn your lights or other scenes on and off. And you can use different touch lengths to cause different actions. As many of you know, I'm not a huge fan of switches. I mean, we all have these clicky, momentary, and toggle switches, and we've seen those god-awful plastic RV toggles. Well, that's not gonna cut it in our full-time home. We want something more elegant. In our van, Shar and I have exactly one switch, and it's by the bed. So in the middle of the night, if we need to get up and use the restroom, we can easily toggle a red light so we can see where we're going. And this is a really elegant solution because we can engrave a little divot here, or maybe even a fancier shape, so that you can just reach up and feel it in the middle of the night. It works great because it's tactile. Now, you could say this is tactile too, and it is, but then in the daytime, you have to look at these ugly plastic Amazon switches. Anyway, this may not be for everybody, but I wanted to share how I built this and show you all the mistakes I made along the way. It's a few dollars worth of parts, definitely a little bit of tinkering, but it's a very satisfying result. All right, let's get into it. All right, I'll turn this around so I can show you how it works. Right now, this is just taped in temporarily, but I'll probably adhere this in on the backside of a cabinet. We drilled this out with a Forstner bit, just like the kind you use for cabinet hinge hardware. It's 35 millimeter Forstner bit, and I left about 6 millimeters of material left in the wood. Then I designed this little 3D printed capsule and embedded my electronic circuit in it, based on an Adafruit breakout board. It's this AT42QT1010. It has its own electrode and LED, so it's super easy to play with and test here on the bench. Let me flip this around so you can take a look at the other side. There's a couple cool features here. For one, you can disable the LED by cutting this trace, and it has jumper pads for different modes. And this is the backside of that LED that we saw. Now, I mentioned the AT42Q had some pretty cool features that set it apart from other more rudimentary touch sensors. One of those is baseline drift compensation. It slowly adjusts its baseline so temperature or humidity don't cause false touches. It also auto-calibrates every time it receives power, it resets itself. And after 60 seconds, if the baseline has changed, it resets the baseline. So essentially, it's learning what no touch looks like over time. And that's why I chose the AT42Q for Smarty Van 2.0, because I think this is going to adapt really nicely to environmental changes that we might see in a van. If you want to build this just like I did, here's the things you're going to need. First, I started with a piece of copper that I had lying around. Then we're going to need a little piece of proto board. Then of course we need the AT42Q breakout board from Adafruit. This is the 1010 version, the momentary capacitive touch. There's also, I think, a 2020, which is the latching version. Then we need a transistor. This is the 2N2222, some resistors for our circuit. And of course, we need the little capsule. This is my 3D printed one, and this is one of my very first mistakes. I thought it would be nice to have a little exit for the cable here, but of course, when I was potting this in, that meant as soon as the level of the epoxy rose to that little divot, it started to pour out. Even when I tried to fill it with silicone and patch it in, I really couldn't get a nice potting. So I've redesigned this since then to not have the little notch, and I'll just let the wires come up over the edge. Another mistake I made was trusting these cheap breadboard power supplies. I actually built this module a couple of times, and every time I plugged it into the breadboard, I let the magic pixies out. And I thought maybe I was soldering it up wrong, but it kept happening. And then I thought to check the power supply. And while I have this set to 5 volts, turns out the regulator had become damaged and it was outputting 12 volts. So yeah, I fried a couple of these. So the lesson here is keep extra power supplies around and always use a multimeter to verify the voltage coming out of your power supply. All right, so here's the circuit I created. The first thing we need is the AT42QT1010. Ground, output, and VDD. And then it has the electrode here. The next critical component is our transistor. And it has an emitter, a base, and a collector. On the AT42, we need to take ground out to our ground plane, and we'll take VDD to 5 volts. I'm running a 5-volt rail in Smarty Van 2.0 to power things like sensors and switches like this. Then we'll take the emitter to ground. Then we need 2 resistors for the base. We've got 100K here, and we're gonna send that to ground, and a 10K here, and that goes to our output. Then finally, we connect the collector to our digital input. All right, so let's talk about how this circuit works. The AT42 is powered by 5 volts and ground, and when this electrode capacitance changes, the AT42 sends that 5 volts through the output and through our 10K resistor, which activates the base of our transistor. The 2 resistors in our circuit help control the on and off states of our transistor. The 10K resistor between base and output helps allow just enough current to turn the transistor on reliably, while the 100K resistor between base and ground pulls the base to ground when there's no current coming from the AT42 to make sure that the transistor is fully off. And we now have an open collector NPN transistor that is used as a sinking output to activate our digital input. This means that our collector can now pull a digital input to ground. So if we take a look at one of the modules here, the yellow wire is connected to our collector. So if we connect this to a digital input, say like on a Shelly switch or an ESP32, we could complete a circuit, pull it to ground, and trigger digital input. So now that you've seen the circuit, the only thing left to do is put it all together, so cue the montage. I'd like to take this opportunity to say a huge thank you to all Smarty Van members. You are all amazing, and we really appreciate your support. Special shout out Shimby, if you know you know. And a super special thanks to top tier Road Scholars. We're so glad you believe in us. There are several tiers that each come with their own special perks. If you want to know more, click the join button down below. Did you know all members have access to members-only content, like deeper dives into 3D printing, manufacturing bent metal parts, robots, and more? And all members get a sticker with a super special note from me. If you're a member and haven't filled out the sticker request form, you'll find it in the YouTube Posts tab or in the Members Only section on the Discord server. Speaking of Discord, did you know there are over 700 nerds hanging out talking home automation, solving problems, sharing ideas, and helping each other out? It's free, and we'd love to see you there. You can find the Discord link in the description. Members also have access to Shar and Mike's Epic Spots map. Shar has been adding more and more spots, and there will be more to come. All members can access the map to see some of our favorite off-grid camping locations. Shar's even added custom descriptions with important details, including photos. Alright, thanks to everyone for your support. Back to making a Cap Touch module for Smarty Van 2.0. All right, let's take a look at how we might wire this up. I've pulled the 3 leads from this Cap Touch module off of my ESP home controller, and we're going to wire them up directly to this Shelly RGB W2 that's been driving our LEDs. Now this Cap Touch module can technically accept 1.8 to 5 volts input, and I'm planning to have a 5 volt rail in Smarty Van 2.0, so I'm using 5 volts. And for this demo, I'm going to use this breadboard power supply to regulate 12 volts down to 5 volts. It's the same 12 volts that's powering this Shelly RGB W2. So I'll connect 5 volts positive and ground, and that collector wire that's going to pull to ground when capacitor senses touch is going to go to the Shelly input. We'll give power to the power supply, And let's give it a try. There we go. This Shelly is now directly responding to the capacitive touch, all locally. There's no home assistant involved. Now I know what you're thinking. Wouldn't it be nice if this Cap Touch module could accept a wider voltage input range? And it would indeed. I didn't build one in because I plan to have a 5-volt rail, but I know there's a bunch of you out in the community who could build this PCB custom in a matter of minutes. So if you decide to put that together, wouldn't it be cool to do a little round PCB with a copper plane on the bottom and a power regulator so we can run this on the same 12 volts as the Shelly or anything else? If you do, go for it. Let me know. I'll be happy to help distribute those files. If you want to build your own, the schematic and the parts list are linked in the description below. Until the next one, how about one more?